Today I'm going to talk to you about families of quadratic functions. Now on the board here you can see in front of me two forms that we should already be familiar with. The first one is turning point form, where h and k tell us the coordinate of the turning point and a is the dilation factor. The second version is a quadratic just in general form. So a, b and c are constants. And we can use a, b and c to find out things such as roots or the turning point. Now obviously to find the turning point, that's obviously used by the coefficient b, we'll use that, and a. When you factorise the quadratic, that tells us what the roots of those quadratics are, if applicable, because obviously not all quadratics have solutions that cut through the x-axis. And you also can get quadratics that don't always have an a, b and a c. For example, you might just get one that just has an a coefficient of the x squared. Now what we're going to do is explore these kinds of things. So let's have a look at something in the form of ax squared plus c. So as you can see, there's no b. So what we need is some information. So let's suppose there's two coordinates. So we've got 1, 7 and 2, 10. Alright, so our equation goes through these points, and we've got to solve for a and c and find out what those are. So what we're going to do is we've got two pieces of information. I'm going to sub those in. It's going to give me two equations. So let's do the first equation. So we'll use the first coordinate to get the first equation. So 7 for y equals a multiplied by x squared, well, 1 squared, plus our c. So that gives me equation 1. Simplifying that just gives me 7 equals a plus c. Okay? Right, let's do equation 2. Now equation 2, I'm going to use this information here where y is 10. 10 equals a times 2 squared plus c. And again, that's going to be simplified, so we get 4a plus c, and that's our equation 2. Two equations, two unknowns, simultaneous equations. So I'm actually going to subtract equation 1 from equation 2. So, write that down. So let's have a look. 10 take away 7 is 3 equals 4a take away a is 3a, and c take away c is 0, so I'm left with 3 equals 3a. Solving gives me a equals 1. I can now substitute that back into this equation. This one's the first equation. I could do that one, but this one's easier to find what c is. So solving for c, we get 7 equals 1 plus c. Subtract the 1 from the 7, c equals 6. We can now finish this off and say the quadratic equation we were dealing with is y equals x squared plus 6. Now, apart from these two quadratics that we're familiar with, the one thing we haven't written down is one where it looks like it's factorized, but it gives us, it's got a dilation factor. So I'm just going to use E and F for this to have general form, but you've got, of course, E could be plus or minus, same with F. This is also a general form. And this one can be used to find the two x-intercepts and a coordinate. You'd need to have another coordinate to be able to solve for A. I might just do an example involving that. Let's suppose I've got a couple of x-intercepts. So let's go with the x-intercepts being -3 and 4. And let's suppose that this curve also intercepts about the point 124. So what I'm going to do is I'm going to place in the x-intercepts here, because we know that when it's in factorised form we have the x-intercepts, but of course we need to find out what A is. A may be 1, in which case it's just factorised form, but it might not be. So we have to use this coordinate here to find out what A is. So let's substitute all these three things in. So we get 24 equals A bracket x. Now it's plus 3 and x minus 4. Okay, now I've forgotten to put the x in as 1, so I'll just substitute that. Let me just work that out. So I've got to put 24, the 1 in there, sorry, 1 and then. Okay, let's work this out. So 1 plus 3 is 4, and 1 take 4 is -3. -3 times 4 is -12. So I get that 24 equals -12a. Dividing by the -12 gives me a equals -2. what we can say now is the equation of this particular quadratic is y equals -2 bracket x plus 3 and x plus, minus 4. Minus 4. Which is a negative quadratic. So if I was going to sketch that, remember to sketch, I still need to find the coordinate of the vertices. This isn't going to be an exact sketch, but we know that it's an upside down curve, and we also know that it intersects at -3 and at +4. Now obviously we do not know this coordinate here, which we'd need to find if we were doing a true sketch. Right? And pretty much these three equations are what you need to know about families of quadratic functions.